Yes, Paresh.
Take a screenshot of this and send it to the group.
Okay, sure.
Okay, you all will be having guest lecture.
Okay, good evening, everyone. So, I'm Vedant back again, and it was really exciting to see this quiz because some of the questions were really difficult, and well, they were worth it because they were worth 2x points. So, I guess it was justified. And so, what's your point of view? Let's hear from you. We have got so this is the time we'll start with the session in 15 minutes, and now you've got time to discuss. Let's discuss about what are some of the difficulties you have faced in this week, or if you have certain things to ask or say. So you can put in chat, or I don't know if you have option for raise hand. I don't think so. Okay, you can just put in chat, or you can just yeah, you can just, if someone wants themselves to be unmuted, you can put in chat that unmute myself and we'll help you. So is everything going fine? Because we have seen a little depreciation in the number of students who uh, are doing the courses. Okay,
Hello.
Yeah.
Actually, I think the music is really disturbing.
Okay, we'll make sure that doesn't happen next time. We'll keep it on
And
mute.
second thing, I think जो last में questions थे जो कि double points के लिए थे, उनमें time बहुत कम था, I guess. Code ही reach करती रह गई.
Yeah, Sakshi, I think I kept less time because then people would actually type the code in interpreter and run it. So
No.
yeah, it can happen. That's why, I mean, they were conceptual ones.
Okay. We'll make sure that we do something about it. We'll increase the timing a little bit, but again, since it was 2x score, so kind of that was what we were expecting. So no
Keep
problem.
it okay, keep it difficult, but at least give time.
Sure.
And
Thank
also
you.
one thing, when
Uh-huh.
there's 1 second or some like or less time is left, I just clicked the option 2 times, but then it said that time's up, so I cannot do that 2 questions.
Oh, okay. Well, that must be something about internet or something which happened. Um, it's not a problem. See, the main concept behind all of these is learning and our interaction, which are to be happened weekly. So don't worry about it. Like participation is more important, and we are pretty lenient about the criteria for selection in competition. So don't worry about it. So it's totally fine.
Okay.
Any other thing?
Thank you so much.
Thank you. We'll make sure the timing and music. Okay, that's great. Like we got 2 major points, so be just we'll pay attention towards these points for next session. Anything apart from quizzes that you want to talk about? Can you unmute Sakshi, because I guess Anjali was speaking till now. Please unmute Sakshi. Yes, Sakshi. You're unmuted. And okay, we cannot hear Sakshi. Sorry. Anything apart from that? Anyone just that you want to talk about the whole week?
Am I audible?
Yes, you are.
Actually, Vedant, I was talking about DataCamp server. I have completed the course for Data Science Toolbox Part 2, but still on progressing, it is showing 0%. It means I have not earned any XPs for that. So I want to talk, can you please contact the team regarding this? Since last 3 days, I am facing the same issue on submitting the answers. I am not gaining any XPs.
I hope you are using the laptop, like the web version, not the mobile app.
Yeah, Vedant. I'm using the laptop for the completion part for project, but this issue is persisting since last 3 days. Actually, I have also messaged this in the group, but I thought it might be some network issue, but it's not network issue because I have a good network connection over here.
Okay. Okay. No problem. We'll look into it. I did get so many messages. Lots of people face the same difficulty, and if it continues, we'll talk with the team. And never mind. If even if you have completed the course, but it doesn't show the XP, it's not an issue. Contact us. We'll look into it because on our portal it usually shows that thing, even if it
Yeah,
doesn't show
there's
on
no
your portal.
issues, but actually it was when I have when I have searched in the progress bar for in the organization tab, then it was showing late. Well, I have submitted the course yesterday only. That's why if you don't mind, please contact this thing because it's actually very irritating when you have finished the things on time and still you are not gaining what you want.
I understand. No problem. We'll even if it is just late, it doesn't. The label doesn't matter anything. You have completed is a great thing. So no problem. But we'll talk to the team as well.
And can I add something to this, Vedant?
Sure.
Actually, I have noticed that whenever we are solving few questions, it actually shows error, even though if the answer is correct. And if we try to refresh several times, then only again, once we click on the submit button, we are able to proceed to the next question. So even though if the answer is correct, we are facing this problem. I have
So
noticed
is it
this.
happening from last 3 days or it was like always?
No, I've noticed it for one question last week also, and it happened again in this week also. And up to
Yeah,
this week,
same
it's
problem persisted with me too. I have
yeah,
also faced this issue.
Okay.
yes.
Okay. Uh, uh, okay. Whenever it happens next time, just send us a screenshot. Usually there are some small mistakes which datacam cannot capture, and we think that is not a mistake, but datacam is automated, right? The answers are getting checked automatically, and that's why certain times this happens. So next time, just send us a screenshot when this happens. Just you can put it in the group and tag me. I'll have a look into it.
Thank you, thank you. And also, even my XP is not updated. Just for the information.
Okay, no problem.
Thank you.
We'll look into it, Muskan and Shalini. Anything else? Sorry. So as you know, as I said earlier, that we'll be having more live sessions coming up, and this week we are starting with the first live session, which is a general talk about machine learning 101, because upcoming courses will be more about machine learning. And so we have, if I don't know if Victoria has joined, so we'll wait for Victoria to join. She hasn't joined yet, so we can take few more questions if any discussion you want, any discussion to happen about anything. There is totally fine. Do you want something to be included in the program to make it more interesting? We are open for suggestions.
Vedant, can I ask something regarding the web development? I mean, or app development. Are there any kind of courses related with that we can relate with Python or something?
Okay, so we won't be teaching, like there won't be any course which will be web development using Python, because it's more about machine learning, and that's the reason why you're learning Python, because we'll be studying machine learning based on Python. But in the last, we'll be telling you, there will be a session, a live session by me. I'll tell you how to deploy these machine learning projects on a web app, like through a mobile app or a web app. So that will be like a short-term course, just like a talk kind of thing. It won't be in detail, but you'll get a glimpse of it, and I'll provide you resources to go more deep into it, because I believe in data to deployment. There are so many people who create machine learning projects but just leave them at Python interface where you don't have a good interface. But it's always good to extract those projects and deploy them as a mobile app or web app where everyone can use them. So there will be a workshop on that.
Thank you.
Welcome. Um, and about the time zone problem, Shalini, I guess you are not joining from India, are you?
No, I'm not. Actually, I'm joining
So
from Muscat.
from
Muscat, Oman.
okay, That's totally fine because time zone is fine. Actually, one of the person joins from New Zealand, and for her, it's too late. So
Yes.
in for that, we are recording the sessions, and the sessions are available for them, and they can demand for quizzes also. So that shouldn't be a problem. Any other person who is facing the same problem, because we just know few people. We just got to know about Shweta, who joins from New Zealand. She's having problem. I guess even for others, the time zone is perfect, right? If not, just tell us. Okay. We'll wait for Victoria for 5 minutes. Until then, if you have any question, you can put in chat box or unmute yourself. Thank you. If anyone wants to introduce themselves, they didn't do it last time, please feel free to do it. Tell about what projects you're working on. You'll just make some connections over here. So, Atharva, for a while, just can you put that thing on where everyone can unmute and talk?
Vedant, I have enabled the option so
Okay.
that participant can unmute here themselves.
Okay.
Okay.
If you wish, you can introduce yourself and let's hear from you. No one. Wow.
Vedant, I have a question.
Yeah.
I want to ask regarding the competition, which will be held after the completion of this program. Actually, I want to know that what actually that competition will be. Are we supposed to do our own projects, or we will be given some kind of criteria or theme for the projects?
No, you can work on your own project. So once you are divided with the team, you can discuss with that team and take up your own idea, anything social good or something which uses the skills that you have learned in this course, and you can create a project on that. So it will be totally your call. But since we'll be forming a random team, so you'll have to discuss with all of the team members that way. So we'll give you time to. There will be a special schedule for that, wherein you get time to decide your ideas and tell them, and then develop it. So that's how it works.
Okay, so will it be of hackathon type, means we will be given 1 day, 2 days, or a limited duration of time, or
Right.
we will be provided with sufficient time, like a week or a 2 week?
Yeah, it won't be hackathon kind of thing. We'll give you sufficient time to do that. Uh, like I guess, Parish, can you throw light on this?
Yes, yes, I will. See, the thing here is in the last week of your studies, you have a case study. All right. So you are not learning anything new. I guess only a bit of natural language processing is introduced. But apart from that, all the other things you will already be familiar with. So around that time only we will form the team. And so you can discuss for 3 to 4 days. And after that, I guess for 2 weeks you can work. So I guess I have answered you.
Okay, thank you, Paresh. Thank you, Vedant.
Welcome. Okay, Victoria had some issues with the joining system, so she'll be here in a while.
Yeah, I have a doubt. Just want to know if we can take up any problem statement and start working on it once the teams are formed, or are there going to be any constraints put upon them?
So it should be based on like the project should be based on machine learning, like whatever you have learned till now. That's totally fine, and it can be in any domain.
Huh?
All right. Uh,
Anjali, do you want to talk about something, or have you mistakenly unmuted yourself? Okay. Nitya, any other question?
So basically, it has to be machine learning based, but then it can be any problem statement, right?
Yeah, it can be any problem statement.
Alright.
But you'll have to develop it then. I mean, you cannot take any past project and work on it. So that's not allowed.
Okay, so it has to be some sort of a innovative idea.
Yeah, that's why we are giving a long week for that. So you can just work on any idea, and yeah, it's totally fine. So innovative, something new, that will be appreciated.
All right, so are we going to have some sort of a presentation or something, or we just upload our project somewhere and that's
So what we are planning is you'll have to upload your project on GitHub, and also you'll have to record a video about what the project does. So kind of demonstration, and you can have you speaking in the half video and demonstrating the project in the half video.
Okay, sounds good. Thank you.
Okay, welcome. So
Will it be
Victoria,
a whole
yeah,
website kind of thing or just a machine learning project?
just a machine learning project is fine. But if you can do more than that, that will be really good.
Will it count?
Yeah, it will.
Okay.
So thank you for all of your questions. Victoria has joined in. Okay, good evening, Victoria. Like, I guess it's morning for you, so good morning.
Thank you. Good
So,
evening, guys.
so everyone, Victoria is a student at Florida Institute of Polytechnic Institute, and also is a Microsoft Student Ambassador. She expertise is in machine learning, and her course is also in concentrated in machine learning. So we are really glad to have you here. Uh, she will be talking about machine learning 101, and Victoria, these participants at SheCodes will be starting with machine learning modules from next week. So they are kind of excited for it. Right till now, they have completed Python modules, and kind of they're expert in Python. I just came to know when they solved the quiz so well. So
Amazing.
now it's up to you. We are really glad to have you here. Over to you.
Well, thank you so much. Let me just give me a second. I haven't used Zoom in a hot minute.
Uh-huh.
This one.
Do you need? Okay, you have presentation rights. That's great.
Yeah, I was just remembering where the button was. There you go. And do you guys mind if I turn on my camera?
It's good. It will be great. They can see you while teaching.
Nice.
So.
Because I talk while gesticulating, so that might be easier for you guys to understand. There you go. Okay. Ready whenever you guys are.
So are you guys ready? Just put it in the chat. Are you all ready? Yes. Yes. Okay.
Okay.
Everyone's ready.
Okay, perfect. Let's get started. So hi, everyone. I'm just going to try to explain a little bit real quick what I'm going to go through in these slides. I try to do this in a way that it's not as much I'm teaching you how to do it. So I'm not going to give you a demo or anything like that on how to use machine learning. It's not the time for a dog to be barking. But instead, we're going to talk about the technology in itself. Why will you use it so much? Why is it so interesting? And what possible future steps for it would be. I'll try to be as descriptive as I can with the slides in case anyone can't see the slides correctly. So you probably see that I'll read the slides and then explain. That's so if anyone can't see the slides, they can still follow along. Oh, let me make sure this is, come on, there you go. So Vedant already talked a little bit about me, but let me go over it real quick. So I'm an international student at Florida Poly. So Poly is a school over in the US. I'm from Brazil. I'm also the director for Phoenix X. If you guys like hackathons, we might be doing this one fully online and open to all students, so you can apply if you want. I am also very glad to say that I've just been inducted to my school's chapter of HKN, of IEEE HKN, which is IEEE Zona Society. So that was awesome. That just happened like last Thursday. If you have any questions that you can't think of in the end, or if you just want to connect, I did put my social media and my LinkedIn, anything that you want. If you want to connect, go ahead and do it. Just send me a message if you want. I'll be glad to help you with anything you need. So without further ado, let me get into it. I know we're here to talk about machine learning, but I'm going to start with artificial intelligence. And I'm going to tell you exactly why I'm starting with artificial intelligence in a little bit. So, artificial intelligence. Artificial intelligence is the theory and development of computer systems able to perform tasks that normally require human intelligence. That's a mouthful, and that's straight from a dictionary, so maybe it doesn't make sense for all of you. But the idea is to have computers do what humans can do: think, see, speak, not only hear, but also understand. So listen and hear. For example, hey Google, what is artificial intelligence?
Here's a summary from Wikipedia. Artificial intelligence, sometimes called machine intelligence, is intelligence demonstrated by machines, unlike the natural intelligence displayed by humans and animals.
Cool, right? So I have a Google Media. I hope you guys could hear what she said. Just reading the start of Wikipedia about artificial intelligence, but that's our first application, right? Voice assistants. Voice assistants like Google, Cortana, and Siri are part of artificial intelligence. We also have IBM's Watson. So this is a series of different artificial intelligence products, kind of like Microsoft has cognitive services with computer vision, that is, the computer can analyze and see the image, as speech recognition, which is also one of the applications in my slide, which is understanding what you're speaking, maybe doing a translation or transcription. So transcription, when you just write exactly what you're hearing. The coolest one from that one that I used in a project was personality insights, which pretty much what it does is it grabs tweets of Twitter or a text that you give it, and it gives you the personality of the person based on their tweets or the text that you inputted. It's pretty cool. Another application is natural language processing. So NLP is that part where not only the computer hears you, but it listens to you. It can understand. For example, sometimes you're talking with someone and you know each other so well, and you just say one word and they know exactly what you want. Like, you don't look at someone and go, "Can I have some water, please?" If you're very intimate, you can go, "Hey, water," and they understand. But if you just turn to a computer and go, "Water," it's gonna go, "Here's some interesting facts about water," and not actually, I don't know, refill your water bottle if it's an automatized filter, for example. But with natural language processing, that's possible. Maybe not in one word, but 2-3 word sentences that are not a complete sentence, but fragments, and the computer can still understand. The one I enjoy using the most is Louise, which is Microsoft's. I'm not going to go too much into the specifics of it. Just know that it's a natural language processing, and you can use it if you want. This is more later in the machine learning course, I suppose, if you do cover it. This is more advanced, but this is just an overview of artificial intelligence. Now, why is AI important? Why is it important? I have a bunch of stuff in the slide. Again, I'm going to read it, and then I'm going to explain each point to make sure that whoever can't see can still follow along. So why is it important? First, it automates repetitive learning and discovery through data. It adds intelligence to existing products, adapts through progressive learning and algorithms to let the data do the programming, analyzes more and deeper data using neural networks that have many hidden layers, achieves incredible accuracy through deep neural networks, which is previously impossible, and gets the most out of data. So let's go one by one so I can explain and give examples. First one is automate repetitive learning and discovery through data. Now, within automation, and maybe you think of automation in a different way. In one of the industrial revolutions, we had a change from human workers assembling products to machines assembling products. And that was also called automation. That's not the kind of automation we're talking about here. Here, we're talking about, instead of some repeated manual task, it's frequent computerized tasks, right? Because AI is a program and so it works on the computer and is gonna automate computer tasks. Now, you do need some human intervention for this because you need to give the data that the computer needs to learn. It's not gonna all of a sudden just go, hey, I can do this now without you ever even giving me the necessary data to learn it. No, we still need humans to give it the data so that it can learn. And I'll cover a very cool automation later down in our little talk. But then you guys are I hope you guys love it because I absolutely loved it when I saw it. Second one, adds intelligence to existing products. I'm 19, maybe you consider me young, but I still remember the time where we had those Nokia phones or the flip phones that had, you could call, you could send an SMS message, and maybe if you were very lucky, you had a game, probably Snake. And then I remember clearly when Bluetooth came out, or when it became available in my country at least, I was still in primary school and my entire class went insane because now we could share photos and music through Bluetooth. Just connect both phones through Bluetooth and we could get music. I couldn't even imagine that we'd get to this. There's no buttons in this thing. It's entirely touchscreen. We didn't even have touchscreen at that time. And not only that, now we have an AI in this. Hey Siri, how are you doing?
Hi there, I'm pretty good. Thanks.
So that's the add intelligence to existing products. We had a product already, a phone, and now we added more intelligence to that same product. Another example would be in the medical field. This is not only for user that uses it or only for tech side, right? We also have many different fields that use AI. So in the medical field, we had, and this also goes under neural networks, but I'll give you the example now. An MRI machine, normally it just scans and then you need a human that's trained to look at the image and understand what's in that image, see if there's any problems, any cancer, anything. Now, we have an AI in an MRI that can predict whether there is cancer in that MRI as good as a human. And that is incredible. For something that didn't even exist, now all of a sudden, they're as intelligent as we are. Then we have adapts to progressive learning algorithms. So here is the part of self-learning. Yeah, okay, self-learning. So you give the algorithm or the computer some data and you say, hey, I want you to do this. So I want you to walk. Here's the world you need to walk in. Good luck. And using that data, it learns by itself, right? That's progressive learning, or one of the progressive learning possibilities. Or then you have just a machine learning algorithm. You're like, hey, here's this bunch of data, this bunch of images. Tell me which one's a dog. Oh wait, but I just find out there's a new kind of dog. Here, there's more pictures of dogs. Tell me which one these are now. So you're giving it more data and it learns from that new data. And then we have analyzes more data using neural networks. Neural networks, again, is a tad more complicated. So that's going to be in the end there's a little cute video, just 1 minute, that explains neural networks real quick. But it's in the importance of AI, the existence of neural networks, because it makes things so much easier. We have so much more computer power that now we can handle the 5, 6, 7, 8 more thousands hidden layer neural networks. And that helps with creating algorithms, right? So in a neural network, not always, but let's say that always for sake of simplicity, the more hidden layers you have, the better your thing will be. So now that we can actually process that many layers, we can have stronger AIs and better programs to understand the data and understand the world around us. And remember, more data they have, the more accurate they are. Next one is its accuracy. Again, the more data they have, the more accurate they are. And this was not possible before because we didn't have the compute power to run through that many hidden layers. And if you're not understanding what I mean by hidden layers, don't worry right now. There will be a video on it later down, just a 1 minute quick video that I'm gonna explain. So this is where the MRI example would come in. Like, who would think that we could do something like that? Have artificial intelligence not only be able to find cancer, but find it as well as a very well-trained radiologist. And then last but not least, it gets the most out of data. Again, we're back to self-learning here. You give it data and it learns from that data without you needing to do anything. It is like, hey, here's this bunch of data. What can you tell me about it? And it does it. All the answers are in the data. You just have to apply AI to get them out. And that also means that data is more important than ever. Say you have two competitors, competitor A, competitor B. They have the exact same hardware and the exact same machine learning algorithm. But competitor A has better data. It is more likely that competitor A product is going to be better than competitors B because they have better quality and more data. So having data and having good data, learning how to prepare it, has become nowadays very, very important. Good. Oh, and I think I forgot to say, if you have any questions, I can't see chat right now, but at the end, I will answer everything. You have like 15 minutes, maybe a time more to ask questions. So yeah, just letting you know. Okay, next one. Why did I start with artificial intelligence? If we're here to talk about machine learning and the name of the presentation is Machine Learning 101. So in the slide, we have a big circle, right? Big blue, dark blue circle. And it is written, artificial intelligence, a program that can sense, reason, act, and adapt. And we talked about this, right? That was my example. We want a computer to do what humans can do. Speak, think, not smell, not yet at least, hear. And then within that circle, we have a smaller one, a little bit brighter, that says machine learning, algorithms whose performance improve as they're exposed to more data over time. Now, you see how the machine learning circle is inside the artificial intelligence circle? That is because machine learning, artificial intelligence, they're not the same thing, right? Machine learning is a part of artificial intelligence. It's a subset of it. So you can be doing something artificial intelligence related that is not machine learning related. But if you're doing anything machine learning related, you're doing artificial intelligence stuff. So just so you guys can understand a little bit more, on the rectangle by the side, you have artificial intelligence on the top, on the bigger rectangle, and then I have reasoning, natural language processing, and planning. That's outside the smaller rectangle that says machine learning. So if I'm working with natural language processing, I am definitely working with artificial intelligence but I can't say I'm working with machine learning. Now, if I'm working with neural networks, I can say I'm working with artificial intelligence, and I can say I'm working with machine learning. You understand the difference? Sometimes people use it interchangeably, but they're not interchangeable. They're different things. One is a subset of the other. So you can be dealing with one, but not the other. I hope I explained that well. And I'm gonna just low down my voice because I think I'm talking too fast. Now we go into machine learning in and of itself. Again, reading the slides, machine learning is a data science technique used to extract patterns from data, allowing computers to identify related data and forecast future outcomes, behaviors, and trends. It's such a mouthful. And again, this is a dictionary definition. What does it actually mean? We give algorithms some data, and it's going to give us some data back, or identify if the data is related to another. See if you, I'll explain more. I can't explain machine learning without explaining the different kinds. That's just how my brain understood it. So as soon as I go through the application and I'm starting the kinds, if you're not understanding anything, you should start to understand what machine learning is there. So applications, personal assistance, self-driving cars, which is a passion of mine and kind of the reason why I even went into the artificial intelligence field to start with. Language translation and image recognition. I know that some of these applications are also in the artificial intelligence applications examples I gave, but like I said, machine learning is a part of artificial intelligence. So any application of machine learning is an application of artificial intelligence. And if you're interested in language translation, image recognition, take a look at cognitive services. Even if you don't know too much, take a look at the demo they have. They have a demo on the website that's pretty cool. I have a bunch of resources at the end. I will probably share with Vedanth so he can share with you guys, and I can include that link in there as well if you guys want. It's very cool. The natural language processing one, I think, has a little DC Easter egg on it, but not getting sidetracked. Machine learning. So like I said, in my brain, I can't explain machine learning without explaining what different types there are. So we have a thing that kind of looks like a fidget spinner, and I cannot look at it any other way. I am sorry, but it looks like a fidget spinner. In one of the sides, we have supervised learning, in the other, unsupervised, and underneath, reinforcement learning. I'm gonna start with supervised, then unsupervised, and then reinforcement. And this is where my visual stuff is gonna start getting a lot. I have images and animations and a couple of videos for you guys to take a look. So just warning you. Okay, supervised learning. So think of yourself as a teacher when you're doing supervised learning. You have a sheet with questions and a sheet with answers, and you give your student both. And you know how sometimes our college notebooks, if you're in college, even high school notebooks, they have the answer on the back, but you have no idea how to get from that question to that answer. This is what's happening here. And what the supervised learning algorithm is gonna do is learn how to get from that question to that answer. In the case of image classification, for example, is understanding what in the image is gonna point to it being, I don't know, a dog or a cat or a person or another person. Or understanding, for example, if you give it data from last year, can it predict what's gonna happen this year? That's also, we have a question and an answer, right? The input and the output. I don't have my supervised learning image thing is going to be after supervised, so let me go to unsupervised. So, and then we'll explain the difference if you are not understanding it yet. So unsupervised learning is kind of, you don't really know what's happening in the data, or you know what's happening and you know you don't need supervised learning. You need to get a bunch of different data points divided into a number of groups, for example. And that's clustering. That's an unsupervised algorithm. You don't have a question and an answer now. You have data that you feed into the algorithm, and the algorithm is gonna separate it in different categories or give you an insights about that data. So let me, oh, well, that's not what I tried to do. I want, oh, come on. You were working a second ago when you tried it out. Oh, there you go. So we have the animation right there. And this is a K-means algorithm. If you don't know what it is, don't worry. You're not supposed to know it just yet. But the idea is I have a bunch of different points. And I want to separate all these points in 3 groups. So you can see there's 2 here. Just focus on one because they do almost the same thing. One is more accurate than the other. But the idea is I want to separate it in 3 categories. So I have these bunch of data points scattered all around, and I just want to divide it into 3 groups. And you can see the little X's moving closer to the center of the groups. That is what the algorithm does. That's what, in this case, clustering is. It's going to try and find the group and the closest group together. This is very visual, which is very nice, at least for me, because it tries to group all the nearby points into one group. That's unsupervised. If you still don't understand the difference between supervised and unsupervised, this should help. So on the left side, we have supervised algorithm. We have a classification algorithm. What is a classification algorithm? Is when you have, for example, a picture and a label for the picture, and you're trying to create a model that gives you, if you give it a picture, it gives you a label. So just a quick concept thing. Algorithm is what you're using, what you're giving the data to create the model. If you consider, let's see, if you consider your data, your input, your algorithm would be your function, and then your model would be the output of that function. So when you're using, for example, the Google Photos thing, where they separate depending on people, they recognize the face and put it in a folder with people, that's the model. But if you were giving the data, trying to create an app yourself that does that, then you're dealing with the algorithm. I hope that was able to explain. Back to the slides. We have 2 photos of ducks with the label duck, a photo of a rabbit with the label not duck, and what I think is a porcupine with the label not duck. We're getting all this data, all this input, and putting in our function, our algorithm. And then it generates a predictive model or output. If we get the picture, another picture of a duck, and we put it through the model, the output is going to be duck. So it recognizes that it's a duck, and it tells us, hey, this is a duck. If I put the image of the rabbit in, it's going to say, this is not a duck. Now, for unsupervised, we have the exact same images. 3 ducks, a rabbit, and I still think that's a porcupine. But now we don't have any labels. So when we run it to a clustering, now clustering is what we saw here. It divides it into groups. When we put it through a clustering algorithm, it's going to want to divide those into groups. But how does it do that? It tried to see which ones are more closely related to which. And you can see that this example that we're using was pretty good, because it grouped all the ducks together, separated the rabbit from everyone, and separated the porcupine from everyone else. So it's, while supervised learning, you give, in this case, an image and a label, and it's just gonna give you back a label. And unsupervised, you just give a bunch of images, and it's gonna give you little groups. I hope that was better to explain. I hope you understand. If not, Q&A at the end. Don't worry. And then last part of machine learning is reinforcement learning. This is honestly my favorite part. This is where a bunch of the self-learning stuff will be in. And this is where the animations start to go pretty awesome. So if you play games like I do, and you've seen the NPCs, that game AI is reinforcement learning. Autonomous vehicles, reinforcement learning. That cool thing where the computer teaches itself how to walk, reinforcement learning. So in this case, again, I'll use the analysis of a teacher. You're gonna give the computer a treat every time it gets the task right, and punish every time it gets the task wrong. Of course, this is a computer, so you're not exactly giving it candy, you're just increasing or decreasing some value that the algorithm is trying to keep as high as possible. This kind of sounds a bit too abstract, so animation time. Nice. So we have 4 animal-like things walking in the screen. From left to right, we have generation 1, 20, 80, and 999. Now, first generation immediately falls as soon as the animation starts. Generation 20 walks a little bit and falls. Generation 80 can walk pretty well, but they have a big neck, and the neck wobbles in what seems a weird, quote unquote, weird way, and also the tail. It's like it's wagging too much, and you're starting to think, wait, this is not correctly balanced. But generation 999 is nailing it, walking perfectly, keeping the posture. And remember, this is a computer that is trying to teach itself how to walk. Now, what does these generations mean? Is this the generation 1 failed, so the programmer went there and like tweaked with the code, and oh, now generation 20 walked a little bit, let me tweak the code again? No, that's not normally. That can be done, yes, but that's not what's happening in this image. What's happening here is the computer is trying different times. Each generation is a different trial. Generation 1 was the first time the computer tried to walk. Generation 20 was the 20th time, and then 999 was 999th time. And by then, it was nailing it. It learned how to do it, and it could do it almost perfectly. But so each generation is what you guys will learn. That is an epoch. So an epoch is when you go through the entire data set that you have once. Although it is not always, but sometimes more epochs means better accuracy. There is a sweet spot, and there is a way to go too many, but I'm not going to cover that part. Not here, at least. I absolutely love this animation, but let's continue. Now, I want to talk a little bit about the future of machine learning. As I said, that was what we're doing, right? I was going to give you a quick interview to the technology itself, and then I'd be explaining what the future of machine learning looks like. You guys are learning it now. What are you probably going to have to deal with if you go deeper into it? First, improve the algorithms. And here, I don't mean simply the algorithms we use to train our models or our functions. I mean stuff like your Netflix recommendations, your YouTube recommendations, Amazon recommendations. It's better personalizations, which is our second bullet point. Better personalizations. It's going to be more personalized to you, more than it is now, and better. Because sometimes you're scrolling through things and you're like, hey, I don't actually like this. And it gets better and better and better, so that after a while, you're just not going to see things you don't like, or you're not going to be, the algorithm knows you're not going to be interested in it. Remember how at the beginning I talked about automation and I said I had something really cool to show you guys? This is it right now. So Another thing of machine learning is going to be automation of tasks. We already have some on the way now. We are going to have plenty more. A good example is, it's not automated AI. I forgot the name. God damn it. So there's this machine learning algorithm where you just give it data and it's going to tell you which algorithm would be best for that data. This is good for when you don't know what's happening in the data at all, but it shouldn't be used always. But it does help, right? Instead of you having to manually go algorithm by algorithm trying to find the best one, that program gives you, oh, I think this would be the best. Why don't you try this one out? But this is not the automation I want to show you. This is the automation I want to show you. OpenAI. Now, this was shown over at Microsoft Build this year. And it's actually on demand. All of their, not all, but most of Build's videos are on demand on the website. And they're awesome. There's a bunch of machine learning and AI stuff. There's also a couple stuff on quantum computing that I'm going to briefly discuss in our section. But pretty much what they did is they took a bunch of GitHubs and gave it to an AI to learn. And this is what they did. Now, it's a long video. We're not going to watch all of it. I am going to jump through it and explain. Wait, I don't know if you can, oh, let me pause it. I don't know if you guys can hear it, but I'm going to be explaining on top of it. Wait, actually, I can check. You probably can't hear it because I don't think I turned it on, but like I said, you don't need to hear it. I'm going to be explaining. That's why I even took the sound off. So let's go. There you go. So this is, if you've coded before, you've seen this. This is just a simple IDE, and he's going to start coding. So did I play? Yeah. So what he's going to try to do first, the first function is simply find if it is a palindrome. There you go. So he's going to type, he's going to start the function. He's going to put a comment of what it wanted to do. And the AI does this. That wasn't him. He didn't just type that. The model they created just made the code based on his comment of what he wanted the code to do. He's going to give another example because he thought this one was too common. So long palindrome, he wants to give the indices back when there is a palindrome in an array that is longer than 7 characters. So return list indices for elements that are palindrome and at least 7 characters is the comment. He runs the model, and the model auto-completes the entire function for him. And the video shows more, but what I want to show is the end of it, because oh no spoilers. So there you go. Hold up, let me speak. Okay. Stay. So he just created 2 classes, and he just wants to create a function that if the item name is a palindrome, you give a 20% discount. Now he just put the name, and the entire rest, including the comment, is all made by the model. And using the rest of the code that was done above, the model completed the function and completed it correctly. And the video goes on and shows more, and they actually create a pretty cool program, but I don't want to show all of it. If you want, their entire presentation is on the MS Build website if you want to check it out. But this is what I wanted to show to you. If you have a very simple program you need to create, and you can just use this, right? of course, you're not going to be using this for every single thing. But something simple, you can use a model like this to make it faster. And that's what automation wants. Automation wants to make stuff faster and easier for us. Next one is quantum computing. Now, I'm not going to go too deep into that because I don't understand quantum computing very well myself. But know that it is going to be very important for machine learning because we can run machine learning algorithms and create models in quantum computing hardware or using quantum computing thinking called quantum computing inspired algorithms. And what this does is make the machine learning process a lot faster and a lot more accurate. So it's going to be very important in the future. Right now, quantum computing is kind of a new thing. Keep that, like I said, keep that in mind. In a couple of years, it might be that you're going to see a lot about quantum computing connected to machine learning. And then we have what is a subset of machine learning itself, which is deep learning and neural networks, which is pretty much revolutionizing the world. Like I said in the beginning of my presentation, we have different programs that we thought would never be possible that's making our lives easier. Now, I did say I have the quick neural networks explained in a minute video, and I know you can't hear the video, but I just want the presentation. Come on. We'll give it a second to load. The video does, and I really like this guy's channel, is it teaches you exactly what a neural network is. So he starts by showing, like, think of neural networks as a box, and then you can put inputs such as sensors in a car, and the outputs are going to be, for example, the wheel or where it needs to turn. The neural network is consisted of neurons, right? All these balls are neurons, and they have many layers. All the neurons are connected using weighted connections. Now, all that means is each connection has an assigned value to it, and so does each neuron. So you multiply the value of the neuron times the connection, and you sum all of those up plus the bias to get the value of the new neuron. I know this is kind of complicated, but you don't need to remember that part now. But the idea is you're changing values and processing this data, and when you get to the end of the network, you have an output, which in the case of the example here is where the car needs to turn to avoid hitting the wall. And the whole idea is finding the correct weights to be able to do that. Like I said, I love his thing, so I have another video that literally doesn't have no audio whatsoever. Oh, come on. No, I love this video. Let me play it. The video is a bunch of cars driving down, trying to drive through a course. And you can see, like, the little blue crosses are the sensors. And I don't know why it doesn't want to work now. The little blue crosses are the sensors. The car that gets the further along is a green car. And he even puts the, there you go. He even puts the neural network on the corner so you can see what's connecting to what as it proceeds. PowerPoint, come on, collaborate with me. I'm almost done. Oh, well. Okay, PowerPoint decided not to work, but I was almost done anyways. So I'll just explain what the video was, and it's in the resources so you can watch it later. it shows many different generations of all these little cars trying to make it through the course. And there's a bunch of curves in the course. Yes, please close it. There are a bunch of curves in the course, and you can see how it measures in the corner, on the top left corner. Let me see if I can share it again. Sorry for the little PowerPoint problem, but we're back to the explanation. You have in the top right, left corner, the values that the sensors are reading, and on the bottom left corner, what generation it is. And it takes it about 60 generations, so 60 trials for one car to go through the entire maze. And after that one car goes through the entire maze, it goes insane. But why? Simply because the car was trained in such a way that it's using the walls to know where it's going, where it's supposed to go. When the car leaves the maze and there's no more walls, the sensors are looking for the wall, so he starts going all around looking for a wall to guide him through. And that's one of the challenges with autonomous vehicles. What are we going to use? How are we going to train these vehicles? And they have to be trained in such a way that it doesn't hurt when, for example, you change the setting of it. That was my last slide, so it's kind of okay that the PowerPoint died now. I have the resources. Vedant, it's your choice. I can put that in the chat now, or if you want, I can send the entire presentation to you and you can send it to them.
Yeah, that would be great. I'll just send the presentation to them.
Okay, perfect. I'll do it as soon as we log off then. But I just put the YouTube channel of the guy, a cheat sheet for algorithms. When you guys start learning about algorithms, you're gonna start loving this, because 90% of the work in machine learning is knowing which algorithm and which numbers you want to put in. And this helps for that. Microsoft Learn, which has free courses on machine learning as well, if you want. A Twitch streamer that doesn't do only AI, but he has a little AI companion. That's the cutest thing ever. A couple articles. You want the MS build, so you can go watch it if you want. A GitHub repository that is not mine. It's from a program I participated in, which was the Machine Learning Udacity Microsoft Scholarship Part 1. That has it's a compilation of different resources. So between cheat sheets and summaries of the courses that we made, and probs and stats cheat sheet, Python, Keras, everything you guys should need. And just in case someone here is interested in quantum computing, I put a project in Hackaday that is learning quantum computing, or in the case of the amazing girl that set it up, teaching quantum computing using comics. So she uses drawings and comics to teach quantum computing concepts. But that's it for my presentation. So it's your guys' floor. Questions that you may have, I'd be glad to answer.
So you can put your questions in the chat box, and we have got a few minutes. I guess we can take a few questions, right, Victoria? Great.
And don't worry, no question is a stupid question. So if you literally didn't understand anything, ask anyways.
Okay, let's give it a minute. Or guys, at least, okay, there's a question.
What's the level of mathematics one needs to know before machine learning, statistics for ML? Level of mathematics, really, right now, in the level I'm in, I haven't found the need of anything much than probability and statistics. I haven't used stuff like calculus, for example, or differential equations. So probability and statistics should be a good place for you to start. And if it starts getting harder, then you can just follow along. Some algorithms may require more mathematic thinking than others, but probs and stats, you should be good. Statistics for ML, EDX, I included that in the resources, has a couple of different statistics for ML courses. But statistics for machine learning is not that much different from normal statistics. It's more that these statistics for ML courses gives you tweaked together with machine learning examples. So while it shows you an algorithm, it shows you, hey, this is the stats concept that you're going to apply to this algorithm. So if you can even do just a simple statistics class and you should be good to go. Okay. And if that didn't answer your question, let me know. How to start with Kaggle. I don't use Kaggle that whole much, but what I did was to just sit down and look through it and trial and error. See if there's any documentation, or if you have a friend that uses it quite often, ask for them. But it's, at least I find it fun, a lot of fun to just sit down and mess through something and see if I can figure out what to do. So just choose a simple data set and try messing with it in Kaggle, and you should be able to start understanding a little bit of what's happening. No, I don't think you need, let me read the question. Should we have more grip on the algorithms for starting with Kaggle? Not really. It depends on how you learn. So for me, I prefer to read everything that I can on a subject before I even start attempting doing stuff, hands-on stuff. Because I want to know, if this doesn't work, this is what I need to do immediately, instead of being, this doesn't work, let me research what I need to do and come back and go and come back. Some people prefer to just go, okay, I learned, I don't know anything, let me start, oh, I need to do this, let's go research how do I do this? Comes back, do it. Oh, I need this. So it's okay if you don't know a lot of algorithms, you can just research as you go. Or if you want, you can read the cheat sheet I gave that explains a little bit. That should be enough to get you going, get you started. If not, the Microsoft Docs has a paragraph or two for each algorithm. That's pretty quick to read, that you can read as well if you want before you start. Again, it depends on how you learn. How to start reinforcement learning, as it sounds a bit difficult, supervised and unsupervised. Yes, it is more complicated than reinforcement learning, and it might take a little bit more of math than supervised and unsupervised. There is Project Bonsai, which is pretty much it's Azure Bonsai. So you can code a brain using a language called Inkling, and they have ready-made programs in there. It's gonna be a shorter code than if you had it in Python, but it's also gonna be more, lose some of the cool stuff that Python can do. So if you want to get started, you can go ahead and use Bonsai and Inkling, but if you want to do it for a career, you're probably going to have to use Python, and that's going to require a little bit more math and a little bit more knowledge of machine learning and the Python functions than supervised and unsupervised. I like Bonsai and Inkling because it's so easy. So if you want to just get started just to see how it goes, I would definitely recommend you go. It's preview.bons.ai. and you need an Azure subscription to do it, but it's pretty cool. And then if you like it and if you want to go more into reinforcement learning, try see if you can get textbooks or courses on it. I know that EDX has a few courses for free. I would recommend just enrolling them, watch through them, see if you can understand. To excel in reinforcement learning, which includes robotics, how can you suggest something on to it? So that's what I was talking about. See if you can get something going with bonsai. You don't necessarily need a robot with you to get started. You can use, like we saw the renderization, you can use that instead. It is more complicated than supervised and unsupervised. It might take you a little more time to understand what's happening and to set one up. The best way is to try to find some course, some introductory course that's gonna give you the basic concepts for it and how to get started. So give you, for example, sample code that you can use to get started. Yeah, I have a bunch of resources. Oh, for algorithms, I have the cheat sheet in there, and I didn't put the PDF of it. It's the link for you guys to download. So that's in docs.microsoft.com. And if you go to the sidebar, you're gonna have the names of all the algorithms, and you can just go one by one and give a quick read. And in the GitHub repository, there's also not only more cheat sheets, but explanations of each algorithm if you go in the note section. I think I went through all the questions I have here right now.
Yeah.
So feel free to send more questions or let me know if I didn't, my answer wasn't complete. Yeah, you're welcome. I'm so happy to be here with you guys, so excited.
So I guess that's it. And we ended right before time. It's 7:53 here in India. And must be somewhere 10, 11, 20 or something.
Yes, oh my God, getting so good at it.
I don't know. So,
Oh, thank you so much for the invite. I absolutely
thanks a
loved it.
lot, Victoria, for joining. I'm sure. Thank you. It was great hosting you, and I don't know if it shows my internet connection is unstable. So I don't know if you can hear me or not.
I can hear you,
Thanks a
but you
lot
sound like
for
a
joining
robot.
in, and we learned a lot. So that OpenAI thing was woo, nice. So you shared a lot of things, and really they were wonderful, and that gave new insights to all of us. And they'll be soon starting with machine learning and everything. So I guess they already got insights about it, and this will. My internet connection is unstable, so I'm sorry. Uh, so, can you hear me now? I hope.
Yeah, I can hear you.
Can you hear me?
Yes.
Hello? 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 Hello?
Dan, can you hear me? Because I'm
Can you hear
saying we
me?
can hear you.
Okay.
Yes. Thanks so much, everyone. I think Vedant just dropped. It looks like it. Yep, I think his internet just died. Oh, thank you so much, everyone. And thank you for coming. Hope that helped. I'll send Vedant the PowerPoint and he sent it over to you guys.
Hello?
Oh, he's back.
Can you hear me? Okay.
Yes.
Thankfully, my internet just went off, and I was like, "This is the wrong time for this to happen." So yeah, about the links, she'll send me the whole deck, and it contains all the resources. So I'll forward it to you either on the WhatsApp group or on your email IDs. So thank you, Victoria, for joining. I don't know if you heard me, whatever I said earlier. So the OpenAI thing and the other resources that you talked about, the graphics, and that really gave a new insight to everything. And there'll be students starting with the machine learning courses and algorithm here in the SheCodes program. And I guess this session will definitely help them a lot than directly jumping over to the algorithm. So thanks a lot. Thank you.
Oh, thank you so much. Love participating.
And everyone, Victoria did share about her social media handles, Twitter, LinkedIn, and Instagram on the very first page. And we'll also share the presentation, so you can connect to her in case you wish to talk about quantum computing or machine learning or reinforcement learning or other stuff. She's great. She will definitely help you. Thank you.
Thank you. Yes, I'll be glad to help anyone.
Yeah.
Stay
So
safe,
there
everyone.
yeah, thank you. Stay safe too. I guess you're in Brazil, we are in India. We both the countries are in top 3 for COVID-19 cases.
Yeah. Stay at home and wear a mask and a lot of
yeah.
gel.
So there we conclude this session. Thank you for joining in, everyone. Thank you for joining, Victoria. Have a great day.